Thanks, everybody. Thanks for having me out. My name is Dylan Chalk. I've been doing home inspections since 2003. And I really appreciate you guys having me out here. I know you've all taken a whole day of your time to be here. So I'm a huge fan of continuing education. Going to things like this in my Washington chapter made me a much better home inspector. And my goal is that hopefully I can contribute in some meaningful, if not small way, to make your company just a little bit better, a little more profitable, make you a little bit better home inspector. That's the goal. I've done it so long, I've sat through a lot of CE classes. So when I started to decide I wanted to make my own, I wanted to try to do something a little bit different. So what do you guys think of the title? I actually got this from reading the directions on a door manufacturer's set of directions. And I thought that was so funny. And when I told my wife about it, she was like, well, hopefully there's no men sitting in the class. Right? Men don't read the directions on things. And I don't like to read the directions on things. I like to just do stuff. I assembled one of these today, and Hollis was like, oh, you installed it backwards. Hollis, should the PowerPoint be on this one as well? Okay, cool. So anyway, the directions. Who here reads directions? Okay, show of hands. Yeah, when you have to. I mean, one common debate in home inspection is, do you do on-site reports or do you do them back in the office, right? And one of the big reasons I like to do them back in the office is I find a lot of the time I want to look something up, whether it's a code or an installation guide or something. So I find reading the directions has helped my business, has helped me be a lot more accurate and find the answers to things. So we'll go over kind of some goals here. What we're trying to accomplish here this morning is learn examples of installation requirements for systems frequently seen on inspections and gain familiarity with reading manufacturers' installation requirements. I have noticed, you guys know Mark Parley, the building consultant, great guy, awesome speaker. And I went through an adhered manufactured stone veneer manual with him, and he was so good at reading it. He was better than I was because he's like, been through all these lawsuits. He's like combed through them. And I must say, reading directions to me is a skill. You would think like anybody can do it, but the more you do it, you're faster at finding the places that you want to do it. So anyway, I hope doing this like encourages everybody to read the directions and not be afraid to dive into them. I think these skills can help you find points of leverage beyond what's spelled out in the building code. You often, if you're doing new construction, you can get builders that are like, oh, that's not to code. Like, well, it probably is just through the directions, right? The code will often point to manufacturer's installation requirements as something that is, part of the code, essentially. I think these skills can help you learn new things, or even more importantly, add a nuanced understanding to stuff you already knew. One of the things that I think is interesting about being an inspector, do you guys feel like there's like mythology that sort of goes through our industry and our profession? There's all this like hearsay and like, oh, temperature pressure relief valve discharge tube should be 6 inches, and that's a great example of one that like, boy, everybody's all over the place on a TPRV discharge and how it should be done. And the code might have one thing, and depending on whether on the UPC or the IPC, there could be different things. And water heater manufacturers have a different thing. The people that make the relief valve have a different thing. So if you don't read the directions, you might not actually know the answer to the question. It's not as simple that I'm still convinced with TPRV, everybody needs to be locked in a room together and they need to come up with one way to do it. But they don't. So you have to read the directions to know whether it's right or wrong. So hopefully this provides you some ways to back up your findings and opinions. Does anybody screenshot directions and put them into the inspection report? I love doing that. I mean, it's a really good way to like end any conversation, particularly with builders. It's like, well, this is what the directions say. So, and if the builder pushes back on it, it's just sitting right there. So I'm a big fan of screenshotting the directions. So some obvious limitations to this class. We're not going to review every single thing of every set of directions. So I'm cherry picking here. When I came up with the idea for this class, I wanted to go through things that I have surprised me over the years when I look stuff up, and I'm like, wow, who would have thought? So I've tried to sort of take that approach to it. So we're not going to be reviewing every single set of directions. It's not conceivable. And part of why I want everybody to be more comfortable reading directions is there's a lot of situations. We're going to talk about CSST in a little bit, which I will probably live to regret. But that's really complicated. If you don't read the directions of the actual product you're looking at, you can't sort of memorize what's right or wrong. There's too many different variables. So I would argue when you start going down this rabbit hole of reading the directions, you will, I think, find, like I did, that more and more you really have to read the directions on some of these things to know whether it's right or wrong. You can't just figure it, you can't know it and memorize it. So cool. Where does one find directions? When I started inspecting in 2003, this was a much taller order. Not everything was online, right? So sometimes you would have to hope you found the directions in a manual or something on site. I mean, now thanks to Al Gore's World Wide Web, we can look up the directions to everything, right? So an industry standard was not to look up directions, but I think that's because we didn't have the ability to do that, So anyway, now we've got data plates, installation manuals, which you can find online of virtually everything, and technical bulletins. These are 3 little honey holes that I look for to find the answers to my questions. These are some snippets from the building code. So let's see. I think I can. This section prescribes performance and construction requirements for exterior windows and doors installed in windows. Windows and doors shall be installed and flash in accordance with fenestration manufacturer's written installation instructions. So these are just examples of the code constantly referring back to the directions. So the code wants you to read the directions. And that's important. The builders will often push back on things that aren't spelled out directly in the code. So this is yeah, we had a question. You probably have to turn it on, yeah.
How about now? A little better. One of the classes I teach is on stucco, and that code that you're reading, I have seen in several municipalities. And the question that always seems to come up, and I'm just curious to know what your thoughts are, is does that suggest that we know more than the township inspectors if they're just referring people to go back to the manufacturer's recommendations for installation?
Can you repeat it? I didn't quite understand it.
So if you read that, I just got to step up to get it word for word. The section prescribe, use the instructions. Where was it? What you just read? Windows and doors shall be installed and flashed in accordance to the, we'll say, manufacturer's recommendations, right?
Yep.
So instead of the township stepping in or the code inspector stepping in and saying, this is how it has to be done, they're saying, just do it the way the manufacturer said.
Yes.
So the question that has come up often is, does that suggest that we know more than the township because they're just saying, just do it the way the manufacturer recommends? So it was an argument that has come up several times, and I'm just curious to know what your thoughts are.
Yeah, so the question, to summarize, I think, is that you can get in this trap where the builder will often say, well, the county approved it, or the so-and-so approved it, so it's, that means it's code. I kind of bow out of that. I mean, if it's in writing, this is exactly why I would go to the directions. Is if they want to say that, that's fine, but I can back my opinion up in writing, and they probably can't, So one of my favorite things, whenever it gets controversial and people push back on you, is like, we'll put it in writing. I did. Here's my report. I mean, one of my favorite stories was I did a deck that needed to be rebuilt, and the seller got an engineer to tell me what a great deck it was and that I was a complete moron and it was the best deck he's ever seen in all of his years of engineering. And I was like, well, I'm sorry I made such a terrible mistake. Why don't you put this in writing with your engineer's stamp on it and send that to my clients? Oh, well, I'm not really an engineer, and I mean, the whole thing just kind of melted and fell apart. So that would be my suggestion if that comes up. And that's the whole point of these directions, is you're backing it up with something that's in writing. Yeah.
Yeah, I've been successful with directions, and products can fail. They can be defective from the original manufacturer process. We know the county inspectors aren't inspecting to manufacturer installation guidelines.
They're probably not.
But in many cases, especially with Hardy products and similar, there are warranties involved.
Yep.
And the written installation guides specifically say if you don't follow these, it will invalidate your warranty.
That's right.
And that's a big deal because those issues aren't going to surface until well after new construction
That's
builders.
another really good point is that you could follow up and say, well, you can install like this if you want, but it's the manufacturer is not likely to warranty this installation. So, yeah,
Exactly. And that's the argument I use. And it's hard for a
I love
builder to defend.
Yeah, no, that's a great point. Cool, guys. So part of the thing I love about my idea when I had this idea for a class was that I can make this class as long as I want. I could keep opening up more directions and find little nuggets out of them somewhat endlessly. So we'll see what we get through today. We're going to try to get through a bunch of this stuff. So it could be like a 10-hour class, I feel like, if I wanted to. So we'll see what we get through here. Kitchen range hoods. The case of the kitchen cooktop fan. So this one happened to me fairly recently. I was in this nice remodeled condo that was built in probably the 80s, and I turned on the kitchen fan, and what do you think I started to smell? The fireplace, the chimney. It smelled like creosote when I turned the fan on. So we all know what was happening, right? We were depressurizing the house and stuff, and so I went and just snapped a picture of the data plate, and I went and looked up that got me on Al Gore's World Wide Web to the specifications. And it was laboratory airflow 450 CFM. So it certainly had the potential to be over 400 CFM, which is the modern code. So here's like a trap, right? My mentor, when I got started, was like, when you're an inspector, you're walking through traps all day long. And the better you get at it, you learn to sort of, tiptoe through all these little pitfalls. But it's kind of tricky on a 1980s house to apply modern code to it, isn't it? Right? So you can't really do that. So in my report, I listed it as a due diligence item, but at the same time, we were having a problem, right? This is an 80s condo. They weren't bringing in makeup air. So you turned the fan on, it depressurized the building. You started pulling air down the chimney into the building. And this is why we changed the code, So kind of cool when you actually see the evolution of like why we make codes and why we change these things is that putting the unit under negative pressure is not really great for it. So I don't know what they ended up doing with that, but it was just this little rabbit hole I went down. But I was able to kind of use the code and the data plate to kind of make my point. They're like, this is why we do this today. And if you don't want to smell your fireplace, you might need to think about doing makeup air, So anybody use due diligence in their reports? I don't know. To me, it's a way when it's not really clear. It's like, well, you can research this yourself and figure out what you want to do with it. Maybe you love the smell of creosote in the morning, and you're okay with it, or you don't use the fan, or there could be a lot of reasons. So to me, it wasn't necessarily a repair item, but I wanted to be clear that, like, what was happening when you smell the fireplace. Cool. CSST. Everybody, do you guys use that out here? I'm guessing. I mean, I think everybody does now, Does anybody else find CSST insanely complicated? I think I'll live to regret doing this part of it, but let's jump in with both feet and we'll see what happens to us. So the first CSST, gas piping, was the yellow stuff, right? And that's not arc resistant. And so does anybody want to raise hands on this? But was special bonding always required for the yellow CSST? Yeah. It was not, right? So a little bit like the whole makeup air for the kitchen fan, things changed, and we realized like houses blew up, and we're like, wow, this seems bad. Maybe we need to do something. So they started requiring special bonding #6 copper for yellow CSST. So then the manufacturers started making black CSST. So now we have yellow and black. And the black, just to make sure we were not, sufficiently confused on all this, there's two types of black CSST. And there's probably more manufacturers. You guys out here could be seeing different manufacturers than I see in the Washington area, Seattle area. But where I am, track pipe is pretty common, and that is the suppressive type of CST, and then flash shield which is also called gas tight, is the conductive type. To me, this is what makes CSST insanely confusing, is you have the manufacturer, you have the brand name, and then you have these different types. And I am just simply not smart enough to remember all this. And it's funny, you guys know Charlie Buell, he's a good friend of mine, and I was lamenting with him that this was really confusing, and he and I sat down with it, and we just barely got through this together to like keep everything straight. So, but we'll keep moving here and see if we can do this successfully. So the counter strike made by track pipe is the suppressive, no additional bonding requirements, vertical runs supported every 10 feet, horizontal runs. So a support is something I'm often see inadequately done on CSST, and you can look in the directions and you can see how frequently you're supposed to support the CSST. So this is where things get tricky, is minimize removing the jacket. So using a utility knife, strip back the jacket, see the table. Care should be taken to minimize the amount of jacket removed. How often do we see lots of the jacket removed? More often than not, right? How do we know they haven't removed the jacket in places we can't see it? No clue, right? So, all right, so here's a picture of that track pipe. This is a really interesting one. Exposed stainless steel that may come into contact with spray foam insulation must be wrapped in self-bonding silicone tape. Are we going to see that one? No idea, no clue, right? But this is a really interesting thing. I partly bring this in about reading the directions because we've now, when we show up at a house, there's like millions of products and they're all layered on top of each other, and we don't always know whether they're compatible with each other. So compatibility is one of those things that I'm actually kind of often like scanning for when I am reading the directions. So I thought that was an interesting one. Probably not much help because we can't see that, but I thought that was sort of interesting. So runs through approved conduit where underground. So if you're running this stuff underground, runs located below grade or under a concrete slab shall be routed through non-metallic watertight conduit. So if you are seeing this run underground, you can open the directions and see what it says about how you're supposed to run this underground to make sure it is done correctly. It can be installed outdoors, but protected from physical damage and not buried directly in the ground. Don't know what's going on with my audio there. So this is interesting. Track pipe counter-strike jacket is resistant to UV and able to withstand exposure to long periods of sunlight. CSST in outdoor systems is certified to the standard. So it can be installed outside, basically the gist there. Not subject to physical damage when it's on the outside. So if you see CSST that could be physically damaged, this is again where you would find in the directions is where you would prove your point that like, hey, I'm worried this stuff could get damaged. And this is, I wanted to bring this up. Have you guys ever had the occurrence where you're inspecting and just intuitively something doesn't feel right? You're like, God, it seems like somebody could drive their car into the CSST. And if you just make it up and you're like, I don't like this, you're kind of defenseless if somebody pushes back. Whereas if you do the outrageous thing, like open the directions and read them and copy and paste this little nugget in there, then you've got these directions have your back. So the directions provide this great way of sort of providing cover for you when you have these opinions or see things. So I hope that helps, but I'm just giving examples of how you sift through and find these little nuggets out of here. This was an inspection I did, and I was like, yellow CST, like not sleeved very well. So I went and found the manufacturer. This is from Gas Tight. Masonry material, they're defining masonry material as not limited to brick, concrete, mortar, stucco. When necessary to install gas tight through the masonry, the tubing should be routed through a conduit that is a ½ inch larger diameter, outside diameter than the CSST. Then there, basically should be sleeved. So clearly, based on the directions, that seemed wrong. And I do think this is something that will change per manufacturer. So I can't stand up here teaching in class, say, when you see CSST and if it's in concrete contact, it's wrong. because I think that there are some manufacturers that will let you do this, which is why I thought CSST was an interesting one to go through, because unfortunately, I think if you really want to get it right, you have to look the directions up. It's too complicated. You can't just memorize one set of rules and assume that it's all the same. Sorry. I wish things were more simple for us, but anyway, 1/2 inch larger diameter sleeve. So you must run into this a lot, right? On the exterior, when you see CSST, they've often stripped the jacket, and it's supposed to have a little, it should always be covered. So that's actually, I think, universal on every directions that I have read. Again, you might want to confirm, like, I can't tell for sure. I can't read every set of directions. But when I have checked this on a number of different ones I've seen, and it seems to me every manufacturer says if the CSST is on the exterior, you got to cover that stainless steel. And that's an easy fix. But you guys see this a lot? I do where I am. This like comes up all the time. Yep. The track pipe jacket is resistant to UV. When installed outdoors, the plastic jacketing shall remain intact as much as practical. Any portions exposed shall be wrapped in self-bonding silicone tape. So they've told you exactly how to fix it. So again, this is the kind of thing and I don't have to look this up every time. To me, this is like why God made software. You know, I can like find this stuff, look it up, put it in my template, and now it's there. And I've snipped the directions in. And so once you can look these things up once and use your report inspection report software to store all this information. And that makes me smarter and faster and more accurate. So that is a really important component to what has allowed me to use reading the directions is I don't have to look it up every single time. But I got in the habit years ago of starting to read these things, and I've accumulated this knowledge. What that means to me as a home inspector is now when I go out in the field, I have on this device a second brain. It's got all these little clips, all these little knowledge is built into my report template, and I'm smarter than somebody that hasn't done this. So I encourage you, like, not only look this stuff up, but like save it and into your report template, and you will be smart, like the bionic man, right? It's faster, stronger. I might be dating myself, you guys. I don't remember. Yeah, there you go. We got some bionic man fans back here. So there it is. There's a little nugget you can put in your reports. So that once again, this is another part of the directions where they're requiring repair of the jacket. So CSST special bonding. So I like to call it special bonding for this because gas piping always requires bonding per the National Electric Code. You know, all metallic systems in the building need to be bonded. For the most part, the steel stuff was all done at the appliance. You know, if you connected it to a furnace and it had a grounded circuit to it, then it was all part of that bonding system there. So the gas pipe didn't require special bonding. The CSST, which is arguably, in my opinion, just a lousy product, now requires special bonding. And the frustrating thing is, who installs the bonding? Probably the electrician. Where is it in the NEC that they should be doing this? Nowhere. So you have a subcontractor, it should be in charge of installing bonding for a material that has absolutely nothing to do with the National Electric Code. So a lot of the electricians kind of push back on it and don't know about it or don't care. So you have to try to get the electrician to care about gas pipe, right? So that's kind of frustrating. But the yellow CSST should always be bonded with number 6. Counter-strike, the suppressive type, does not require special bonding, but you have to repair the jacket. And to me, this is, if I were king, I would make all CSST have to be bonded because I can't tell whether the jacket's damaged somewhere. I mean, you can only see a tiny little part of this stuff, right? So this is a needle in a haystack for us. So I have some language in my reports that if there's CSST, I recommend bonding it, period. And I try to explain that it may not be required if it's a black type and if the jacket is installed well, but that it's hard to tell. So you guys, anybody else have like a technique for handling this? I mean, that's how I've decided to handle it. These are business decisions you make. Yeah.
I don't have a recommendation, but I have a question. Because I've never really seen where they require the bonding to be made. From a common sense perspective, I always I always suggest before the gas line enters the house.
To me, so I love this question. The question was, you know, where is it required? And they don't specify where it's required. The system must be bonded somewhere. They say where it can't be done. You can't connect it to the CSST itself, right? It would have to be some steel pipe or one of the nuts. I have gotten in the habit of, and maybe this helps you, I have developed a knee-jerk reaction to go for my phone every time I see any bonding connection and wherever I see the gas pipe entering the house. Because I don't know what to say, because I may find that bonding connection in the crawl space, in the attic, under a kitchen sink, in the laundry room. Who knows where you're going to find it? But I always take a picture of the gas line entering the house so that I have that in my back pocket ready to go. If I'm done with the inspection and I'd never found the connection, I will put a picture of where the gas pipe enters the house and say, I didn't find it here. It's possible it's somewhere else that I just didn't see, but I was looking for it, and I would make sure that it's bonded. Frustrating, right? These are like these traps, you know? And I mean, if you can not say anything about it, but then what happens, right? So this is tricky, but that joke about my hand going for my phone is just anytime I see any bonding connection like this, I've gotten in the habit of snapping pictures of every bonding connection. And I think that's helped me. Here's a question, like how many of you leave an inspection and feel super confident that the grounding and bonding system is installed and working as intended? Right? It's hard. I mean, how do you know? Like you can't like turn it on like a furnace and test it. And so in lieu of that, and I think it's a really important system that we be looking at. And so it's made me a much better inspector that I was just taking pictures of everywhere that I did see a connection. And then I actually put those in the report. I'm like, hey, I found bonding at the water heater on the copper pipes. I found a ground rod out here. And at least I have proven in my report that I've found these certain connections. And I'm assuming based on me seeing these that it seems like it's done right. Whereas, and the best part about it is because I gotten in the habit of doing that, sometimes I get home and I'm like, I don't have any pictures of grounding and bonding. And that's my kind of clue now of like, it might not be done right. Because that's a hard one to remember, isn't it? You guys always remember to look at grounding and bonding connections? I mean, that's a really easy one to overlook, isn't it? Yeah. So does that help? I mean, that's my advice, is just take a picture of them, you know, and so you're sort of confirming that it is there by just taking pictures of the bits you can see. So great question. Hopefully that's helpful. So the conductive, the gas-tight flash shield does not require special bonding unless the jacket's compromised. So again, I'll let you come up with your own thing that you like for your business, but in general, if I can't find bonding, I recommend it for the most part. And I have a comment that explains that the black stuff technically might not need it, but that I can't confirm that. Hey, we're doing pretty well with CSST, right? So far, so good. All right, cool. Let's see. So this is just a picture of the flash shield. So this is the conductive type. And it actually has this whole little, this sheathing that goes on it, which is kind of how you can tell it. So I don't know, sometimes you see cool illustrations and stuff in the directions that help you understand how the product works and you learn more about it. This is kind of a cool illustration where you can see that metallic shield that is meant to go over the flash shield stuff. So again, I like the directions because it just helps me learn more about a product. And I mean, who here knew there was a conductive and a resistive, or whatever those two types are? I mean, I saw black CSST for years until I understood that there were two different types, and I figured that out by reading the directions. So you learn stuff when you start digging into these things. And this is the gas tight. They've got all kinds of stuff on the special bonding that's required, and they're showing the clamp and so forth. If a tear in the outer jacket is greater than a ½ inch in length, gas tight recommends wrapping the tear with electrical tape or self-bonding silicone tape to provide continued protection to the metallic shield layer. If the metal shield layer tears greater than ½ inch, it must be cut and replaced using appropriate methods. The affected area of greater than a ½ inch metal shield tear cannot be cut out and replaced. System shall be treated like yellow gas tight and with regard to isolation separation requirements. So you can see here, they're actually saying if you have damaged this metal beyond a ½ inch, it should be treated like the yellow and bonded with the yellow CSST. So again, I'm just trying to show you where I found this stuff and how I came to my opinions about this. Good little nuggets. This is an interesting one. Must only be installed by an installer who has successfully trained through the flash shield training program. That can be really helpful, right? If someone's pushing back on you and it's like, hey, you know, have anybody seen some of these where they're not sure that they've taken the class? I mean, I've definitely seen some of that. So this would be, you know, you could put this in. I don't think I have this in my library of like, make sure that they are, but that might be something I could add to my library of pre-made CSST comments. How about that? We made it through CSST. No, everybody survived that? Cool. Yeah. So, good stuff there. So error codes, who looks up error codes when they see them on appliances? This is an easy one, right? It's just sitting there like, sometimes they're flashing at you. It's like the appliance is telling you something. Let's look it up and figure it out. So different appliances where I'm looking for error codes, heat pump and tankless water heaters, generators give you error codes, HVAC equipment, AFCI, GFCI breakers, kitchen appliances, laundry appliances. Anywhere that you see any kind of an LED light, sometimes they're just flashing in a sequence. Sometimes it's a display where it says some weird gibberish, but either way, you can look it up and see what it's trying to tell you. So they often are completely inscrutable, right? That's like, I don't even know what the heck this is, but I saw that and I thought to myself, something might not be right. And so I did the weird thing of looking it up and I found the directions and ECC, heat pump compressor is not functioning. That's a pretty good thing to know, right? I mean, that'd be a bad one to miss that and then have the client move in and have the heat pump not working on the water heater. You guys have heat pump water heaters out here? We have quite a few of them. Do you guys, I like to get a video of the compressor running. So I go in and run hot water till that thing kicks on and I have a video of the compressor running to prove that it was running when I was there. And I'll even take it and put it in the mode. You know, sometimes people have disabled it and it's not in the heat pump mode. So I will put it in the heat pump mode, turn on hot water to see if that thing is running. I obviously can tell whether the water heater is making hot water by just testing the water temperature. But with these, I like to make sure the heat pump's working. You guys see that? Good little tip, can kind of help save you. I mean, I've found a lot of these not working over the years where there's hot water. The elements work, but the heat pump part of it is not working, or at least didn't respond to my operating controls. I might not say it doesn't work, you know. But in this case, it was slam dunk. And I just, you know, just got a screenshot of this diagnostic code and put it in. And the client was really grateful for me that I found that the heat pump wasn't working on the water heater. So I kind of fussed about this one because I figured I couldn't get it to come on. It gave me the error code and I thought that they should have it fixed. Composition roofing. I've been driving around since I got here and I can tell you guys have composition roofing around here. Let's dive into this one. So this is one of my favorites. So remember we talked earlier about the idea of you go out and it doesn't feel right. Who here feels like it doesn't feel right when the upper downspouts drain onto the lower roof? 50%, something like that. I mean, you know, anybody been to the Grand Canyon? You know, water, like water is some ornery stuff, man. Like you do want to control that, and running it onto the roof will damage the shingles prematurely. So the problem is, if I call that out and say you should fix this, do I have any real backing for it in the building code? Not that I can find. I can't. And if you go to a new construction cul-de-sac development, every single house has the upper downspouts draining right onto the lower roof. So you're tilting against windmills here. You're Don Quixote out in the wilderness with nothing to have your back. My buddy Charles Buell made this nice illustration I love. We include those in our software, Scribeware. But I always have that in my comment. But you know, this isn't my first rodeo. I've done this a lot. I know what happens if you let the upper downspouts drain onto the roof for 20 years. You know, that becomes the first place that the roof fails, isn't it? Am I wrong? Right. So I know this. So So then when I see this and it's not bad, I'm going to use GAF's technical advisory bulletin. So again, most manufacturers have technical bulletins that you can find that can be really helpful. And in this case, their technical advisory bulletin, it's actually worth reading this. The shingles directly below the gutter outlet or downspout can occur. This erosion will gradually expose the asphalt that's beneath the granules, accelerate the weathering at reducing the shingle life. Erosion may be visible in 1 or 2 years or less. Leaks may occur due to the high volume and force of the water. Algae, mold, fungus, moss, or other vegetation may grow near the discharge. Sidewalls may be damaged if the discharge point is near a wall. So GAF kind of has my back, doesn't it? Again, I look at these things as like, these are people that have our back. Like, we want to say this stuff, but we don't want to be out in the wilderness. This Don Quixote tilting against windmills. Yeah, we got a question in the back.
Could you go back to that previous slide and explain that solution?
This one?
The one before that. That one, yeah.
Yeah.
I don't understand that. Can you explain?
Yeah, the idea would be that you could build a little pan to collect that pushes the water down to the lower gutter.
What would the pan material be? And
You would give it a nice little water slide so that the water is not running onto the shingles. Right? I've only seen this like 3 times in my life, but I have seen it out in the wild. And you know who the people are that install these? The people whose last roof looked like that. We learn by pain, yeah, right? I mean, that's how humans learn. And so in my experience, the clients that actually extend these downspouts had a roof that failed prematurely. And we're like, yeah, we're going to do this. So yeah, and you could also, you don't have to do a pan. You could run a downspout extension all the way down. That's what I see more common.
Yeah, it just looked like by that diagram, it was some kind of clear material, but you don't know.
Yeah, how I've seen it done is with a metal pan that just runs all the way down. Yeah. Yeah.
I see a lot of them where they'll run the drain for the condensate into the spouting up top, and it runs down across those shingles too off of that drain, and it really eats up the shingle. That condensate water is acidic, so it really eats it up.
I think I couldn't totally hear all that, but about condensate from a gas discharge.
Yeah, on an attic mounted unit, they'll run it into the drain or into the
yeah.
gutter, then it runs down across that shingles, and it eats them up.
So that would be
really
another
fast.
thing I could add to this presentation, right? Would be all the gas appliance manufacturers are going to have specific places that you can and cannot discharge their condensate. And that condensate is very acidic, isn't it? So it'll wreak havoc on all kinds of different things. So again, when you see stuff like that and you want to say something about it, you have 2 choices. You can say that I don't like this, and you're Don Quixote out in the wilderness, or you can go look up the directions of the appliance manufacturer and have some entity that has your back, you know. And that's really time consuming. But as I said, over time, what you'll find is you get better and faster at it. And if you're smart, you add it to your template. And over a couple of years, you've got a lot of knowledge built into your template. You don't have to keep looking it up every single time, you know. But yeah, great point on the condensate there. So anyway, GAF, they've got your back. So shingle fastening. Who here checks shingle fastening on composition roofs? If I can, right? I don't take a pry bar and like lift them. If it's sealed, I actually have a note that it's sealed and I can't see the fastening. But if I can lift them, I'm going to see whether, when you check them, how often are they perfectly fastened? Yeah, it's like never. I mean, they almost never. Like, there's one company where I work that does hand nailing. They will, and that's their big thing. They only hand nail a composition roof, but everybody else uses a compressor. You ever see those videos on YouTube where the guys are like, bap, 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 and they're like showing the world how they're not installing their shingles correctly, and like really proud of it. It's funny to me, but in any event, believe it or not, you can look up the directions, and there are a location on the shingles that you're supposed to nail, and there's a certain number of nails you should have per shingle, and you can look this stuff up. And this is a hard one because is anybody as bad as I am at trying to figure out which manufacturer a comp shingle is? That's a hard one. So I often don't know the directions. So that can be a real limitation if you don't know who installed it. Sometimes I'll find a package of them in the garage or the crawl space or something. I'm like, ooh, sweet. Now I know who installed the shingles. So I love looking for a bundle, leftover half-used bundle somewhere. But sometimes I don't know, and that puts you at a little disadvantage. But there is a little fastening strip where the fasteners should be located. This is how they most often look in my experience, where they're high fastened, because they don't want to have shiners. So when in doubt, they put them too high on the shingle. Nail shingles with 4 nails. They give you the size of the nails from the bottom of the shingle, or how far up from the bottom of the shingle. In the nailing areas as shown, nails must not be exposed. Staples, 2003. Does anybody build that into their report template? I can't remember that they stopped letting us do staples in 2003, but I can put it in my report template and I can type in the word staple and it pops right up for me. And I'm like, sweet, 2003. But that helps me date a roof, is that I kind of know when a roof was installed. Most likely, if I see staples, like it's an older than 2003. Do you guys see stapled comp roofs here at all? A little bit? I mean, they're kind of going away because that's getting to be a pretty old comp roof, so I don't see them much anymore. Yeah, question in the back.
Comment you had on, it's hard to tell what manufacturer it is. A lot of times I will go to the association, not to the general manufacturer, because most associations have installation guidelines
Cool.
that cover all their members.
Love it. Now, you're talking about the Roof Manufacturer Association?
Yep.
Yep. Okay, cool. I love that.
Vinyl siding has their own association. The lick and stick companies have their own association.
Yep.
And all of them have details that all of their members agree on.
I love that. And it can get confusing, can't it? Like, I know that with adhered manufactured stone veneer, there is like a nationwide manual that I like a lot. But what I've actually found is that if you get the product, it can be different than the national standard. So I would argue that the product probably trumps the national standard because that's the actual product that you're using. So I would be careful with that, because I've got into trouble with that with the manufactured stone veneer one. The AAMV, the Association of Manufactured Stone Veneer, they have a really nice guide and I like it. But in that guide, just as an example, they require all the transitions between windows and stone veneer to have an expansion joint. And I don't think I've ever seen that in the directions for the actual stone, if that makes sense. So a great point, and they're out there. And this is, if you make a case like, I don't want to read the directions, it's like, because you can get into trouble, right? You can go down a rabbit hole that could be the wrong one. And it is a risk, but I would say the more you read the directions, the more you get better at it. It's a skill like everything else. So. Anyway, 2003 staples. We're probably not going to see that many staples anymore. They're kind of going away. But so I like to check fastening, and if you tug on the shingles, they're often loose if they're not done well. That's a good. You guys check that they're sealed in the valleys. Even on brand new roofs, they often don't do that. So this is a really common. You guys ever get hired to come out and inspect a brand new roof, just the roof, because the seller doesn't trust that the roofer did it right? I love doing that. Good job. So, but then if you're doing that, you might want the directions. So when I get hired to do that, my first question is what manufacturer is the direction, and I'll go look it up and make sure I have that so I can refer to it. It's a nice little income, and it helps people a lot, because I mean, where I am, the roofers are not perfect. They make a lot of mistakes, and I can often catch them. So, but I'll check the valleys, and then if it's not done, overlap shingles at least 4 inches. They have things in millimeters, which I find completely useless. Anybody else hate the metric system as much as I do? It makes 10 times more sense, but in the metric system, I'm completely helpless. Embed the shingle ends in asphalt plastic cement to seal the shingles to the metal and keep water from running under them. Pretty clear. It's right in the directions. This is a really easy one. Interior doors. Doors used in this building. Recommend sealing on all 6 sides. You guys ever run into this one? Like the wood doors say right on the top of them. Does everybody remember to look for this? I don't. When do you see it? When I'm going into the attic, and the door's partly open. I'm like, oh, I forgot to look for that, right? I always forget to look. But particularly on a new build, I don't usually call this out if it's not a new build, just because I sort of figure like no one's going to pull all the doors off and redo it. I don't know. You could still, I'd make a note of it maybe, but I'm not going to call it a repair item. But if it's a new build, like it says right on the door to do it, and they didn't do it. So I don't know. I call it out. Did anybody else call this out? Yeah, I got a couple hands. Yeah. I don't know. It would look embarrassing if the door is warped and your client read that and was like, how come you didn't say something about it? So I say something about it. So you must have propane here. Guys, not everybody's a urban city person, right? You live out in the country here, you got pieces of land. So secondary pressure regulators. I didn't even know that was the name of this thing for a while. So that was like, oh, okay, they call it something that I didn't know. I thought this was really fascinating, not the California cancer thing, but things to tell the gas customer. I bet that never happens, but this is what the manufacturer put in here. Show the customer the vent assembly and vent lines. Stress that this opening must remain unobstructed at all times. Tell the customer to check the vent opening after a freezing rain, sleet storm, or snow to make sure ice has not formed on the vent. Show the customer the shutoff valve on the container. The customer should close this valve immediately if gas is smelled. Appliance pilot lights fail to stay on or appear higher than usual, or any other abnormal situation occurs. Tell the customer to call your company to service the regulator if the regulator vent, gas, or leak develops in the system. Only qualified people should work on it. Well, that could be helpful, couldn't it? I don't know. I thought it was really interesting that that's in there. This is pretty cool. Who thinks of these as having a service life? Who knew, right? Well, if you read the directions, 25-year recommended replacement life. So there's a life to them. They recommend replace them every 25 years. That's their design of corrosion-resistant materials, both internally and externally, with proper installation. They will meet a 25-year recommended lifespan. Screen drip lip is oriented either over the inlet. Yeah, that's not it. But anyway. This is a really good one that I see wrong all the time. Install the regulator with the vent pointed vertically down. You guys see this not done correctly a lot? Maybe you don't look. Who knew, right? If you read the directions, it's like, wow, I can't believe this. This is something I should have been looking for, and I wasn't, So install the regulator with the vent pointed vertically down. If the vent cannot be installed in the vertically down position, the regulator must be installed under a separate protective cover. Installing the regulator with the vent down allows condensation to drain, minimizes the entry of water or other debris from entering the vent, and minimizes vent blockage from freezing and precipitation. Cool, I learned something new, right? Again, these are like, I hope this is helpful for you guys, but I didn't know any of this stuff, right? Nobody teaches it in the schools really. And so you read the directions and you learn all these things. It's fascinating to me. Install the regulator so that any gas discharge through the vent or assembly is over 3 feet horizontally from any building opening below the level of the discharge. Below the level of discharge, that's an important one, and not less than 5 feet in any direction away from any source of ignition, openings into the direct vent appliances, or mechanical ventilation air intakes. So clearances can get really confusing, can't it? I mean, sometimes you have a secondary pressure regulator, a direct vent water heater, a direct vent furnace, a crawl space opening. So we've got 3 manufacturers, we've got the building code, all of these things start layering on top of each other. I mean, I've definitely had a few houses where I'm like, I really have no idea of what's right anymore, because you've layered so many different manufacturers on top of each other. And who starts taking precedent over who? I mean, you start having to figure out who's like the worst one and stuff. So this stuff can get confusing when there's multiple systems and clearance issues at play. But if you have any hope of sorting it out, it's going to be in the directions. Yeah.
The other one is sometimes your builders will say, we got a waiver for that. Because I see a lot of gas regulators of any kind underneath windows.
So
And
I'd say this again. So I can't quite hear, but so you said people will tell you they get a waiver for that?
builders in large developments,
Okay.
specifically townhouses, will get waivers from the gas company to say they can put regulators underneath operable windows.
How cool. So if you are online and you couldn't hear that, what he's saying is that the builders will sometimes say, hey, we got a waiver from the city for this installation to say this is okay. And I would say, that's awesome. Will you send it to me? And I would put that in my report and be like, the builder says that the city says this is fine and here's where it is in writing. And if they can't send it to you, then it's just worthless, right? I mean, just hearsay. But I love that. That's really interesting. And I don't think I've ever had that. You know, I did have happen once in a big development, and they put the gas meters in, and then later the guys cut the dryer vents in, and every dryer vent was right next to the gas vent. Like that was just because it was the same, or at least in every floor plan that was like this. And they had to fix like hundreds of them. Like they had to go back, and I think I was the first person to call it out. But the gas company didn't know because the dryer vents weren't there when the gas got put in. So sometimes, you know, these things on a new build can like happen in a sequence at which not everybody has thought it all the way through. That actually brings me to one of my favorite things I've read in any instruction manual is in the James Hardy manual. I teach a class. I used to teach these classes with reps from James Hardy. And so I had some fun classes with that. But there's a little line with like a box in the directions for mounting blocks, right? And they require mounting blocks wherever there's a hole greater than 1.5 inches, I think it is. Yeah, I think that's it. And there's a big, and it says, warning, this may require some planning. That's great. I mean, it's like, this is the thing in America with residential construction, like we don't really plan this stuff, do we? I mean, there's like a crude, here's how it'll all stand up, but nobody's, the architects are not planning every vent termination ahead of time, are they? We're making this up as we go along. And so that's why we can run into these things where it can get kind of confusing with some of the manufacturers and clearances. It's also why arguably we might be the only people capable or able to figure some of these things out, because the builder's not going to figure it out. The AHJ might not be able to figure it out because they don't have enough time on site. The subcontractors, they don't know these things. Right? You guys know in Hardy, there's a 1-inch clearance between the gutter and the siding, right? We all know that. How many of the gutter installers know the directions to the siding? They don't. I mean, the only reason they might is if someone like us called it out and they had to go fix it. Other than that, there's just not a chance that they would know that. So anyway, sometimes it falls on us. Like we're the only people capable of figuring this out, I think. That's sort of why I take it seriously and try to look at this stuff, because sometimes I think we're the only ones that could figure it out. But thank you for that comment. That's awesome. Yeah. Heat pump water heaters. So we went over the error code earlier, but I'm glad you guys see these because we have a bit on them. So in location requirements, indoors, so you can't install them outside, vertical and level, that seems fairly intuitive. Unrestricted airflow. So they do want at least 750 cubic feet of space, roughly 10 by 10 by 8 feet tall, right? So if it's in a small little closet with no makeup air, then there's probably not enough air for that heat pump to work right. Minimum 6-inch clearance on all sides. I very rarely see that, right? I mean, they're often up against a wall. Who's going to like move that? I mean, so these are these traps we run into. I mean, people get kind of tired of us being picky, right? But this is a home inspector trap. Well, it says there's supposed to be 6-inch clearance on all sides, and there isn't. I don't know. Do with it what you will, but it's right in the directions. Not subject to freezing. Well, that's kind of interesting. If they're in a garage, which is a good location for them, they could freeze where I am. It's funny. I was just down in Arizona, and nobody puts heat pump water heaters in Arizona, which might be one of the strangest things I've ever heard. I was like, there's like so much free heat down here. Why in the world aren't you using these in Arizona? Plus, it'd cool your garage for you, so your garage isn't like 150 degrees. But anyway, they don't do them down there. Free of corrosive elements. So that's kind of interesting. What if you saw one next to pool equipment? Right? Next to spa equipment, and it would actually be right in the directions that you shouldn't install it with that stuff nearby. Ambient air temperatures. In efficiency mode, the ambient air temperature should not be less than 45 or more than 109. Maybe that's why they don't install it in Arizona. It's too hot for them. Temperatures lower than 145 degrees will turn off the heat pump and the elements will kick on. not subject to physical damage by cars. What do you guys notice about this slide that I took right out of the directions?
The water heater, shouldn't that be 18 inches off the ground?
Yeah, that's kind of interesting, isn't it? The water heater's right on the ground in the garage, not 18 inches. What else? There's no bollard. You know, they just have like a little curb thing. So it is interesting, like the whole bollard thing I could probably add that. That'd be another. This was fun. Like I could teach this class and come up with like 30 more things we could do every time I teach it. But bollards and like who makes the bollard and like what are their directions and what does the code say about them? And the code is very unspecific about bollard installations unless it's commercial. And like on the exterior of commercial buildings, those bollards have to be like dug into the ground and reinforced with concrete and all kinds of very onerous requirements. But in general, like in your garage, they don't seem to. Does anybody kick bollards? Charlie Buell taught me to do that. He was like, I kick them. I'm like, oh, that's probably a good idea. I've kicked a few and had them come right out, you know? So do what you will there. But anyway, I just thought that was interesting. They're not really specifying a bollard, but the water heater shall be located so it's not subject to physical damage by moving vehicles. So a bit of an interpretation there. Confined space requirements. So if you do find one in a closet, they've got all kinds of little things you can read about this. Heat pump water heaters covered in this manual require a minimum of 750. We did that. Inlet air will be delivered from an alternate location inside the building structure, though, through one or more louvered grills or through a fully louvered door leading to the conditioned space. The alternate location from where inlet air will be delivered must provide a minimum of 750 cubic feet. Anyway, they've got all these directions for bringing in makeup air. Do you guys ever see the makeup air vents on these? Every once in a while I do, but they're pretty rarely. They're usually just plopped in there. And to me, they don't really make a lot of sense putting it in a conditioned space, really. I mean, that you're just robbing Peter to pay Paul. I don't understand the efficiency benefit there. So to me, the whole point of a heat pump is I want the free heat that's on the outside of the building. So I don't know why they wouldn't all come with a vent to the exterior, but nobody asked me when they made these. So that's how they are. So there's some stuff about install a shutoff on the cold water side. Oh, all right, sorry, water piping, there's a whole thing here. So 3/4 inch. So that's, you guys ever see 1/2 inch pipe to the water heater? Sometimes you do, and they put a little reducer to it. So 3/4 inch, they're saying right in the directions. Mixing valves may be required by local codes. A pressure reducing valve may be required per codes on the cold water inlet. Install a shutoff on the cold water side. Thermal expansion may be needed if it's a closed loop system, right? So sometimes we wonder about requirements for the expansion tanks or some type of thermal expansion. So if it's a closed system, some type of thermal expansion might be needed. And I thought this was interesting, is the system should be installed only with piping that is suitable for potable water, such as copper, CPVC, or polybutylene. So inadvertently, the water heater manufacturer seems to think polybutylene is okay. Isn't that weird? Like the stuff you find in these directions. You know, when you start reading the directions more, I've started to wonder, like, well, who's writing these and how much do they know about all this stuff, right? I mean, you sometimes get some head scratchers. Notice how it does not allow for PVC water piping. So there's another place that, I mean, for obvious reasons, right? But another spot. And when you read the directions, you get all these cool little illustrations that you can start picking apart. I don't think I found any particular wisdom here. There was all kinds of interesting little, you know, in Massachusetts, they have like special requirements for vacuum relief and stuff. So I don't know, it's kind of, you can see how much fun I am of what I do on my spare time and I think is interesting, right? I think this stuff's cool. So I read a lot of these things. If an adequate drain is not available for condensate drain lines, then a condensate pump must be used. Do not discharge the condensate drain lines into the metal drain pan. So somebody brought up condensation earlier. Thank you for that. And So here you can see they're specifying. I did an inspection on a new build. I did the new build when it was brand new. And then I did a 1 year, they're actually selling it, but I showed up about a year later, and I was, the heat pump water heater was in the garage. There was a bathroom right behind it, but obviously a wall in the way. And I used my moisture meter around the toilet, and I got high moisture meter readings. And I was like, toilet must be leaking. Went down in the crawl space and was like, wow, it's really wet under here. Like there was like rot and like, damaged I-joists and stuff. And I was like, this is a big deal. What the heck's going on? And I figured out that I missed on the first inspection that the condensate wasn't connected. There was really no way I would have been able to find it. It actually had a discharge on the outside, but they never connected it in the wall. So for a year, this thing was just dumping condensate onto the subfloor, or basically into the wall, creating this whole water damage thing. Luckily, everybody was nice to me about it. And, I don't know, you can't see some of these things, so it's hard to know. But that was one of my lessons of like, you really ought to try to see where the condensate is going and make sure it's connected if you can at all see that, Do not connect condensate drain lines with other drain or discharge lines into a single common pipe or line. Each line, condensate line, temperature, pressure, relief valve, discharge pipe should be independently run. So there it is. If a condensate pump is installed and should shut off the heat pump in the event of the condensate pump fails or the float switch and the pump activates. I don't know why I put that in here. It should shut off the heat pump, right? So those condensate pumps typically have those 2 extra wires on them. And if you don't connect those, then it won't shut off the appliance that they're going to. So that's actually something that I look for and have a pre-made comment of whether those 2 wires have been serviced. And here the directions to the manufacturer, like saying, hey, basically saying, hey, hook up those extra 2 wires, right? I should get a picture of that, put it in. So thermal expansion in closed systems. If the temperature pressure relief valve is dripping or leaking, have a qualified person replace it. Examples of a qualified person include licensed plumbers, authorized electric company personnel, authorized service personnel. That's kind of interesting that the directions are saying who's qualified. Do not plug the valve, do not remove the valve. Is this a good complete list of temperature, pressure, relief valve discharge requirements? No, right? To me, CPRVs are just an absolute nightmare when it comes to directions and code. They're all different, and they all come with these little snippets of things, and I can't go to one place to just be like, here are the rules, So just, if you're frustrated, so am I, and we have a right to be.
On that line, it's only been relatively recently that building code standards have required the thermal expansion tanks on water heaters, but they've always been required in the manufacturer installation guidelines.
So I bet thermal expansion tanks are not specified, if I'm guessing. So usually when I've read the directions to all this stuff and in the code, there's a provision for thermal expansion. So there's actually other ways to do it. I can't remember. There's something called a Watts 80, I think it is, and that can be in the toilet, which God, good luck finding that. Anybody here pull every tank cover of a toilet? I don't. You do. Nice. That's awesome. I should. Something I should get in the habit of. I do usually when there's no stuff on it, but I hate all the doilies and there's stuff on them, and then I just get frustrated and don't pull it, but I should, I'm of the opinion that we could always spend more time doing an inspection and charge more money and deliver a higher quality service. I think that's always possible. So you could open up every tank cover. So anyway, but this is, and we did not always, we didn't require any thermal expansion devices until we started having closed loop systems or closed systems. So once the system is closed, which is usually a pressure reducing valve that closes it, then you start going into thermal expansion stuff. That's my understanding of it.
Well, yeah, but around here, it's only been since the 2013, 2019 that building code started requiring expansion tanks in a closed water system
Mm-hmm.
in a house. So for a lot of years, you would have the backflow preventers installed, and with new construction. But when water heaters were installed, they weren't necessarily installing the expansion tanks on the water heaters.
Mm-hmm.
And but again, the manufacturer guidelines have always had references when there are closed water systems to requiring some control for thermal expansion.
Yep.
And that's been my argument when building codes
Cool.
did
Interesting.
require them.
So your point is basically that even though the code might have started around, when you say 2013,
2013 and 19,
cool.
before it may have been implemented.
But your point is that in the directions to the water heater, they may have been referring to recommendations for thermal expansion, presumably if it's on a closed system, right?
Yes.
Yep.
If it's on a
Yep.
closed system.
Everybody good with that? I mean, this is kind of complicated conversation. That again, that's why the directions are so important. Is you have a lot of moving parts with like manufacturers and the code, and these things don't always jive in a clear way. And I've found that reading the directions has helped me see through some of this stuff more effectively than when I would just read code. Yeah, Wilma.
When I teach my classes, when we're doing the plumbing section, and as I start talking about TPR pipes, and my students here will remember that I always pull up the Mythbusters exploding water heater video, just to give the demonstration of just how dangerous plugging up the TPR pipe is. Because it actually, they demonstrate that by plugging a TPR pipe, it turns the water heater into this bomb that goes through a 2-story house and, several hundred feet up in the air. And it's rather dramatic. And I always advise people to go look at that video.
Yeah. I mean, the TPRV, one of the things that I try to explain to particularly real estate brokers, because we get a lot of eye rolls from them, right? And I explain that my job is inordinately preoccupied by low probability, high consequence items. The odds that you need your TPRV to work are not likely. If you don't have it, in Seattle, we have a big highway called the I-5. It's like 6 lanes or something. It's this massive highway. And in the city of Tacoma, in a commercial building, a water heater TPRV did not work, and the water heater shot through the roof of the commercial building and across I-5. These things are like, this is a big deal, right? So I don't know. That's the task that we are faced with, is trying to keep people safe in the face of a lot of low probability, high consequence things. So anyway, I mean, you will find different stuff with discharge relief in the water heater manufacturers, in the TPRV. I mean, you have like the code, you have the IRC, you've got the UPC, you've got the water heater manufacturer, you've got the relief valve manufacturer. In my opinion, the relief valve manufacturer trumps them all. Like, that's the one that if I were really wanting to know whether it's right, I would figure out which relief valve was installed and go read their directions, because I think that's going to trump all those other ones. And it's just a nightmare. That's all over the place. Everything is different. So I'll let you wade through that on your own. I can't fix that one. But anyway, they have, in the water heater, every water heater will usually have some amount of stuff in there for how the relief valve should be done. And I find it's very rarely comprehensive. It seems like somebody picked and chose a few things that they should put in their directions. It seems kind of arbitrary. This is a really fun one. Who here tests voltage on electric systems? Anybody? So residences, anybody find a residence that's 208 volt?
What?
I never have. I did one time. This was weird. It had 2 200 amp services, so a big hot gutter, and 2 200 amp panels. One of them was 208 and one of them was 240, which I still don't understand. I called the utility to ask them about it, and they didn't understand it. But in any event, if you do commercial buildings, who here does condos? Who here does commercial buildings? So if you do condos and commercial buildings, you'll find a lot of them are 208 volt. And so I like to test that, and you can put leads on. But how interesting, the heat pump water heater says water heater do not use 208 volts. Who knew? So this is, I have gotten in the habit of reading the data plates on 240-volt appliance equipment when I'm in condos. I try to test the voltage and make sure that they're rated for 208 volts. You will find that occasionally those things don't jive. Most systems, when you read the data plate, will say 240, 208. They'll have different wattage ratings, and they're able to be installed on both. But so it's actually not that hard to test. I use one of these little fluke testers, and you just put your leads on the, I mean, really any part of it that would give you normally 240 volts. And if it reads 212 or 206 or whatever, a 208 volt system. So anyway, it's a good thing to check. If you're doing condos, in how I got into this in Washington State, in our SOP, we are required to report the voltage, which is really interesting. I don't know how it kind of slipped into the SOP. It's not an ASHI thing. Are you guys, do you have this in your SOP here? Or you guys test voltage, you just do it because you care? Or? Yeah, that's how I am. What's that? It is a Maryland standard. Okay, well, there you go. If you're watching on the internet and you're in Maryland, then that is something that you should do. So you can buy one of these testers, and I think it's really fun and interesting. I like testing for it. And again, you're very unlikely to find a single family residence on a 208 volt system. But it is probably plausible. And you get 208 when you're on 3-phase systems. I mean, that's why you get 208 volts. So if I met a guy that's wanting to do commercial inspections here, and if you're doing commercial, there's probably a lot of 3-phase and a lot of 208 volt. Insulation blankets. The use of an insulation blanket on this water heater is not needed or recommended. How cool. The purpose of an insulation blanket is to reduce the standby heat loss encountered with storage tank heaters. Your water heater meets or exceeds the National Appliance Energy Conservation Act standards with respect to insulation and standby loss requirements, making an insulation blanket unnecessary. So they're pretty clear about it. I hate insulation blankets because you can never get to the data plate, right? I mean, and you can't like see the whole water heater. So if you don't like them, you could actually look up. I've never seen that in the regular water heater. We're in heat pump water heaters, but they're not recommending it. TPRV maintenance manually. So this is interesting. I have a note in my reports in my template that auto-populates when I inspect, when I connect and I hit TPRV present, I get a note that's not totally dissimilar to this. It's like, hey, I don't test these because they could get stuck on, but the manufacturer suggests that you, the homeowner, test these annually, which they do in writing, most TPR manufacturers that I've read. So manually operate the temperature and pressure relief valve at least once a year to make sure it's working properly. To prevent water damage, the valve must be properly connected to a discharge line which terminates at an adequate drain, standing clear of the outlet. Discharge water may be hot. Slowly lift and release the lever handle on the temperature and pressure relief valve to allow the valve to operate freely. Return to its closed position. If the valve fails to completely reset and continues to release water, immediately disconnect the electrical power, close the cold water inlet valve, and call a qualified person. Kind of a cool little thing, isn't it? I mean, what a nice thing that actually shows why we don't do it in the middle of home inspection. That it could get stuck open and we could have this whole mess and we have to shut down the water heater. So this thing has your back in a lot of different ways, doesn't it? It's sort of saying like, what can happen if you do test it, that you should test it, and that this should be part of regular scheduled maintenance on your building. Anybody include things like this in their report? I have a nice ability to have background information that is not going to the summary and is kind of clearly not, I'm trying to teach people how to like be safe in their house. So it's easy for me. This is my comment. So I have a little, thing. It shows how you can test it and goes on a bit, but it's just background information. It's not going to the summary page or anything. Draining and flushing. It's recommended that the tank be drained and flushed every 6 months. We all do this, right? I mean, I don't think I've got my water heater is like, 15 years old and I've just never touched it. I haven't tested my relief valve. I'll go home and do it. But I'm not going to drain the darn thing. It takes too much time. I'm too busy. It's recommended that the tank be drained and flushed every 6 months to remove sediment, which may build up during operation. The water heater should be drained if being shut down during freezing temperatures. To drain the tank, perform the following steps. I can't remember. I don't think I included all that, but anyway, they tell you how to go ahead and drain the tank. Alice, how are we doing on time? How long? Half an hour? Cool. All right, wood I-joists. You guys have these around here? Yeah, yep. I would guess, but just checking. So there's some really good stuff in here when you read the directions. These are from Weyerhaeuser, which is a Washington state-based company. Do not cut holes into the cantilever. So that's kind of interesting. So where it's cantilevered out, do not cut or notch the flange. I think we all kind of know that, right? I mean, these things are very convenient compared to, regular sawn lumber for, you can notch them in all kinds of places. It's way more convenient than sawn lumber. But the top and bottom flanges are kind of sacrosanct, right? We want to leave those alone. That's kind of easy to remember. They don't want you to notch where there's load points there, where they're landing on the posts. So that's something to watch out for. I don't think I've ever found that. Anybody seen those cut? You guys have? Yeah. So good thing to keep looking for. I mean, these are hard to inspect often because you can't see them on the second floor. There's sheetrock covering them, and in the crawl space, I have a lot of crawl spaces, so they're usually pretty covered in insulation. So I'm kind of flying blind. I'm like trying to pull back insulation in a few spots to see what's going on, looking for squash blocks. But these are hard to inspect. I'm sure I've missed things on them. So yeah, no field cut holes in the hatched zone. Then they've got minimum applies to all holes except knockout. So some of them have pre-made knockouts that you can just knock out, which is super convenient. And then they've got some minimum, sizes, but they're really pretty darn forgiving. You can see that D1. I mean, geez, you can cut huge holes in the middles of these things. Closely grouped round holes are permitted if the group perimeter meets requirements for round or square holes. Round holes may be cut, 1.5 inch round holes may be cut anywhere in the web outside of the hatched zone area. So again, that load point you got to be really careful of for 6 inches. That's a good one to remember. But even near the beam, it looks like as long as you're outside of that 6 inches around that load point, you can do 1/2 inch round holes. So this is a good table. I mean, this is hard stuff to remember, right? I can't remember this. Like if I see weird things in these, I take pictures and I have to go look it up. I mean, I can't, I'm not smart enough to remember this stuff. What's going on here? Anybody see anything funny? What's that? Yeah, nominal, like sawn lumber with wood I-joist. Yeah, this is kind of a good catch. I try to check whenever I see these. If I can get to the rim joist, I try to check. Do not use sawn lumber for rim border blocking, as it may shrink after installation. Use only engineered lumber. Would this be an easy fix for it? That'd be a big deal, huh? Yeah. Yeah, this is a good one to look for. I mean, it's one of those ones that sort of makes your heart race a little bit of like, wow, that'd be a big find. So I've seen this a couple times and I'm always like, whoo,
Did they drill holes in the flange for wires, or am I looking at the picture wrong?
It's got to be a bit louder. Sorry.
Oh, I'm sorry. Did they drill holes in the flange for wires? Are there wires running through the flange there, or am I looking at the picture wrong?
Yeah, there's no holes in it. Yeah. No, there's no holes in this I-joist here. Yeah.
Oh.
Yeah, so anyway, the rim joist. So if you see I-joist, try to get to the rim and see if you see sawn lumber. Worth having a look. So they have this whole TGI floor framing diagram. I think there was one thing. Joists are unstable until laterally braced. And they've got but boy, this is hard to see in a crawl space. You guys probably have a lot of basements here, don't you? Yeah, so basements, you have a much more of a fighting chance of actually seeing how all this stuff's done than when it's a crawl space. Do you guys look then for the, you know, like cross bracing? Can you see that when you're doing these? I really can't in crawl spaces where they're all covered in insulation. I mean, you just can't. I try to look for the squash blocks, you know, I try to like find, you know, go to the beams and then like look up and see if there's any blocks and stuff. This is hard stuff. It's hard to find for me anyway in crawl spaces. I just feel like I'm kind of flying blind. I think I grabbed that, yeah, that sawn lumber thing. This is the illustration that it comes from. Do not use sawn lumber for the rim board. So this is what I was saying, squash blocks above load-bearing walls. So if you can try to figure out where load-bearing points are, just trying to look that they actually use squash blocks, this can be kind of a tough one to find. So wood I-joists and fire protection. This must come up for you guys a lot if you have basements, huh? You have a lot of gas heating equipment around here? Yeah, so this one's tricky. So this was a crawl space I did. They had the boiler in the crawl space. The house was built around 2000, so it kind of predated the fire code requirements for protecting wood I-joists when there is equipment. So you guys all know about this? We can kind of go through this a little bit, but the code to me is really confusing on this. So floor assemblies not required elsewhere in this code, which I'm already confused, to be fire resistance rated shall be provided with 1/2-inch gypsum wallboard membrane, 5/8-inch wood structural panel membrane, or equivalent on the underside of the floor framing member. So they're basically saying you have to have fire protection, and then they back their way into where it's required or not with exceptions. Does that make sense? I mean, it's so confusing, but this is how they often do these things. So exceptions: floor assembly is located directly over a space protected by an automatic sprinkler system. Do not need fire protection. That kind of makes sense, right? If you have a floor assembly is located directly over a crawl space not intended for storage or fuel appliances. So where I am, most of my buildings are crawl spaces. And so as long as there's not a fuel-fired appliance down there, you don't require fire protection. But that is interesting, not intended for storage, isn't it? That's starting to be a gray area. I mean, you could store anything in a crawl space at any point, right? So I don't know. I don't fuss much about it unless it's like a walk-in type crawl space. And then I feel like people could be parking lawnmowers and things in there. Like if I have to crawl in there, I usually don't bring it up. But if it's like basement-like, but just unfinished, then I might bring it up. But that's kind of a tricky area. Portions of floor assemblies can be unprotected when complying with the following. The aggregate area of the unprotected portions shall not exceed 80 square feet per story, so kind of smaller areas. Fire blocking in accordance with R302, blah, 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 shall be installed along the perimeter of unprotected portion to separate the unprotected portion from the remainder of the floor assembly. That's kind of confusing, right? And then the wood floor assembly using dimensional lumber or structural composite lumber equal to or greater than 2x10 nominal dimension or other approved floor assemblies. So what about a 2x8? So they're saying that 2x8 would require fire protection. So this is where like now we're getting into, you know, I brought up the code because the manufacturer talks about fire prevention, but then a lot of this stuff's actually in the code of what requires basically drywall or 5/8-inch structural panel membrane. So here's straight from Weyerhaeuser, satisfying the code for fire protection requirements. TGI joists with flak jacket protection have been discontinued. So has anybody seen this stuff? I haven't because I don't see it much. So you guys have. What do you say about this stuff?
That it's not approved anymore and they should have the manufacturer take a look at it.
Yeah.
to-
Anybody else have I mean, you have something built in your template for this stuff, or I mean, this seems so. Well, let's read it. It's been discontinued due to recent customer feedback regarding an odor in certain newly constructed homes. The issue is related to a recent formula change to the flak jacket coating that included formaldehyde-based resin. The issue is isolated to flak jacket product manufactured after December 1st, 2016, and does not affect any of the company's other products. To learn more about flak jacket protection, I think they have a link that you can click on. TGI joist with gypsum. Installing a gypsum membrane to the underside of TGIs meets code requirements for fire protection of floors. This makes TGIs an excellent option for basements that will be finished. TGI joists are engineered for superior performance and with several joist series and a variety of depths to choose from, blah, blah, blah. So anyway, I have not seen this flak jacket protection, but that seems like something you'd want to build into your template, know what it looks like and look for it. Yeah, go, please tell me more.
It was David Goldstein in New Jersey. He did a presentation about flak jackets specifically. It was a
Awesome.
2-hour thing at one of our conferences. And basically it was a formaldehyde thing. The chemical stuff was making people sick. The manufacturer changed it a couple times, but inevitably just discontinued it. They used it in place of gypsum or something like that to fireproof their structural assemblies.
Yep.
And it just turned out to be a bad product. Imagine that.
Can you smell it? I mean, like how would you identify it?
So given that I just sat in on that presentation, I've never actually seen this in the field in the wild, you know?
Okay.
I think it was mostly in the Northeast or something. There were like pockets of it where it was installed, and it was pretty short-lived, I think. So there's not a lot of it out there.
Yeah. This is what's so great about coming together to these conferences, isn't it? I mean, like you get some weirdo like me out here from Seattle, and like I know what I know, but then you guys might talk at the break and be like, you know what, I actually found this stuff, or I didn't, or we don't have it here. Like, and I had a lot of that over the years at Ashley, Washington. We'd get speakers from all over the country, and then I'd try to find the guys that knew what they were doing and ask them, like, well, do we see this here, or what's going on with it? So yeah, cool. Well, I thought I would bring it up. I thought that was kind of interesting. And again, these are the things when you start reading directions, you go down these like Byzantine rabbit holes and you start learning things. So this was a basement I did that had a boiler in it, and it was a basement. So it had storage, and it was built prior to the requirements for this. It was built around 2099 or 1999. So I use improve or upgrade as a modifier in my report, you know, I mean, to me, that's a really important thing. If I go into an old house, a house built in 1920, are the stairs to code? I don't have to get out of the car. I mean, you just know they're not, right? And so to me, it's really helpful in your reports to have an improvement or upgrade type recommendation that can handle all the like old code stuff, you know? So in this case, it didn't feel like, I don't know, that's a gray area. Maybe it should be a repair item, like it's a fire safety thing. Trap, right? There's a home inspector trap that I just walked into the middle of. Do you make a big fuss about this? Do you call it an improvement? Do you call it a major concern? Do you call it a repair? Do you not call it anything and just hope that your client can figure it out? I'm not a fan of that one, but that's how a lot of people handle these sorts of things. So these are the business decisions that we are tasked with. If you want to own a home inspection business, you got to buckle up your pants and make a decision here. So current building standards require that I-joists, wood truss, floor framing assemblies have a minimum. So I'm repeating what it says right in the directions and in the code. This started as a 2012 requirement for floor assembly. So this helps me when I've got this built, this comment is in my report template. So when I see this, if it's like newer than 2012, to me, this would be more of a repair or major concern. If it's older than 2012, it feels a little harder to be able to fuss about this because that's not what was required when the house was built. Again, gray area that we go into, but then I include links to both the Weyerhaeuser recommendations and the 2012 code. I know you're not really supposed to put code in reports. I've never had it bite me in any way. I don't know. I do. But you know, a lot of the wisdom from lawyers and stuff is that you shouldn't ever quote code because then everything in your report has to be in code, or that's sort of what I hear. I don't know. I've never had anybody be able to prove to me that an inspector's gotten in trouble for that, but that's what you hear a lot. So I'll let you make your own business decisions on that. All right. Clothes dryers. Good airflow, along with heat dryers require good airflow to efficiently dry laundry. Proper venting will reduce your dry times and improve your energy savings. Venting system attached to the dryer plays a big role in good airflow. Blocked or crushed vents, as well as an improper venting installation, will reduce airflow and dryer performance. Service calls caused by improper venting are not covered by warranty and will be paid by the customer regardless of who installed the dryer. To clean or repair venting, contact a venting specialist. So kind of like somebody brought up here that, you know, if you don't do it according to the directions, the manufacturer is not going to look after the warranty, right? That's what they're saying here. Cleaning your lint screen before each load. Replace the plastic or foil vent material with 4-inch diameter heavy rigid metal pipe. You guys see number 2 on there? I mean, I don't think you will find a manufacturer that lets you do the foil or the plastic transition duct. Anybody seen one? I never have. They all require the heavy rigid vent material. So use the shortest length of vent possible. Isn't it insane? Sometimes they don't want the vent in the front of the house, so they'll run the thing like 100 feet in a different direction. That's just not going to work nearly as well. So I kind of will often recommend, you know, rerouting things. So use no more than 4 90-degree elbows in a vent system. Each bend and curve reduces airflow. Remove lint and debris from the exhaust hood. Remove lint from the entire length of the vent system at least every 2 years. So who here puts like clean the dryer vent in their inspection reports? So if you can attach this little screenshot of the directions, like, hey, this is what the manufacturer says. This isn't on me. I'm not being Don Quixote out in the wilderness. This is like, I'm just telling you what the directions say. So again, I think the directions have your back for a lot of these things. Who here has heard that you can't do plastic dryer transition duct for a dryer? I mean, I'd heard that for years, and I don't know, to me, it was just sort of one of those things like, okay. And then I realized like, well, that comes from the directions. Like that's where it comes from, because I don't think that's in the code anywhere, at least not directly. Clear away items from the front of the dryer. So they tell you about the different cords, right? Because sometimes in older buildings, it's a 3-wire feed to the dryer. Sometimes it's a 4-wire feed. So UL listed 30 amp power supply cord. If your outlet looks like this, choose the 4-wire power cord. If your outlet looks like this, choose the 3-wire power cord. So they're trying to walk you through the different cord sizes. I will often note whether it's 3-conductor or 4-conductor. The 3-conductor one will be usually a gray, you know, if you don't want to unplug the dryer, they're usually gray color. So you can just note that for people so they're aware of it. Again, you don't really have to. Only a 4-inch heavy metal exhaust vent and clamps may be used. Do not use plastic or metal foil. So that's the second time they put it in the directions. So that they don't want you to use the plastic or foil vent, which is interesting. I believe the plastic and the foil vent both have a UL listing. What's that? Is that right? Okay. Yeah. So the wrong product. Yeah. Recommend for best drying performance to avoid crushing and kinking. Must be fully extended and supported. Remove excess to avoid sagging. Sometimes you see these like huge serpentine transition ducts, and they don't want you to do that. Do not install in enclosed walls, ceilings, or floors. So the transition duct, the flexible stuff, shouldn't, you know, there should be rigid material that comes out of the wall or the floor or the ceiling that is you're attaching the transition duct to. Do not install enclosed walls. Total length should not exceed 7 3/4 feet. So that's kind of interesting. And then a lot of them will have these reductions every time there's 90s and stuff. So this is for that flexible vent, not for the entire. Sorry, yeah. So you wouldn't see a reduction for this because that's just the flexible vent. But the rigid vent, I think, is 24 feet. And there's a company out where I am that actually will put a placard on new construction of the total vent length and the total equivalent length because they subtract for the 90s. I always love when I see that. We're always flying blind, right? Nobody like writes this stuff for us, so we can't figure a lot of things out. So, yeah, go ahead.
I'm also seeing those placards because they're running the dryer vents long. And I see this on new construction mostly. They're saying, oh, we're installing a dryer rated for a higher exhaust vent.
Oh,
Like,
interesting. And they're putting a
so-
little placard
so
for you?
therefore It's got to be posted. So when that dryer gets replaced, occupant knows.
Okay. That's really, really good to know. Cool. I love that. I've never seen that. That's why I like the local knowledge. We'll try to talk about that in my second class here. So there's the foil stuff that they don't recommend. Notice how that's actually connected to a fan. So in condos where I am, sometimes you'll see an additional booster fan with the dryer because they have such a long vent to run. And that's a whole other manufacturer. So now you have 2 sets of directions for the same thing. 3 sets, right? You got an exhaust fan, you've got the foil manufacturer, which it turns out is for bath fans, not for dryer. And then you've got the dryer manufacturer. So this stuff can get confusing.
I've also seen at least twice interior dryer vents. So these devices that say, oh, don't lose the heat from your dryer out the wall, vent it back into your house.
Where did you read that?
No, I've seen them. I've seen it at least twice in inspections where these boxes, so the dryer vent doesn't go outside at all. It vents directly into the house.
Interesting. I mean, you know where I think in places like Mississippi, you can vent up into the attic because it's like it would dry the thing out. You know, I mean, it's so hot and humid down there. And there would be certain locations in the country where it's so dry, you might be able to get away with it, right? I mean, anybody ever been out to Crested Butte, Colorado? Man, that place is dry. I mean, you show up and you have a nosebleed. It's like 10,000 feet. Like it's so dry. So anyway, there would be places you may be able to do that, but not in like normal habitable places, right? Yeah,
They're actually making condensing dryers now where there's no vent.
that's correct. That's right. And that actually is a tricky thing on the code, isn't it? Of whether, so if you're doing a new construction and you see a heat pump, you know, vent-free dryer, do you look for a vent so that somebody could put, because if they don't put a vent, then you're stuck with a vent-free dryer. So do you guys say something about that? Kind of, there's another home inspection trap, you know, and you get into some code stuff of whether a vent would actually be required even if you're not using it, so that the next appliance could be. So my friend Charlie Buell has a class that I took one time called anticipatory report writing, which I love the concept of you're trying to anticipate all these different things that are going to happen after you've been there. So even if it was a heat pump water heater, or my comment when I see a vent-free dryer is I make a comment of like, hey, this doesn't have a vent. They also tend to have these like condensation pans that can make a mess. I recommend they, you know, sort of familiarize themselves with it because it kind of different behavior and you need to keep it clean. And then I do try to look to see if there is a vent in case they wanted to change it. There's a condo that I did that is a platinum LEED build. And so all of the outgoing air goes through a heat recovery ventilator. And these have vent-free gas appliances. So vent-free dryers, sorry. So you can't put a vent in without like disrupting their whole model, their whole energy model really, right? So that was like, I have a comment specifically for these condos that I run into. Yeah, you had a comment or question? No? I thought someone was raising their hand. Okay. Let's see. So they have a recommended exhaust installation. This is all stuff you can kind of find in the directions. They've got different hoods you can use. Boy, one thing that I wish is, well, let's read exhaust hoods. An exhaust hood cap and vent to keep the rodents and insects from entering must be at least 12 inches from the ground or any object that may obstruct the exhaust. So that's kind of interesting. How often do you see them like right on the ground? So I didn't even think, yeah. Yeah, that's right. It makes a lot of sense with the snow level. But that there again, like you might not like it on the ground, but now if you read the directions, you've actually got somebody behind you there. Do not use an exhaust hood with a magnetic latch. So that's another kind of interesting ones. Personally, I wish they would outlaw the plastic vents for dryers. Anybody else find that they melt and they just like the backdraft dampers don't work very well quickly? You know, I really like a nice heavy gauge metal dryer exhaust vent. I don't care so much for the bath fans. It seems like they work fine, but I have never found anything that prohibits the use of a plastic dryer exhaust vent cover, but I kind of secretly wish that I could find something like that. Cool. And then they talk about clamps. I mean, this always seems like a ripe area for somebody to invent a better way to exhaust a dryer, doesn't it? I mean, all those like weird bits of metal you have to fit together. Nothing. Have anybody installed dryer vent before? I mean, it's a total pain in the butt to put those together, and you're not supposed to use screws, and you're like taping these things. Anyway, I wish there was a way to thread them together and they were just better made, but they aren't. So it must be at least 12 inches from the ground. Do not connect the dryer exhaust vent with screws, says right in the directions. All right, so venting length you can get in the directions. So you can follow this chart below. If you do not use vent runs longer than those specified in the vent chart system. These will shorten the life of the dryer, reduce performance, resulting in longer dry times, increased energy usage. The vent system chart provides venting requirements that will help achieve the best drying performance. So a number of 90-degree elbows. This is the chart I was kind of referring to earlier. And so if you have none, you can go 64 feet. If you have one, you can have 54. So this is not something you're likely to memorize, but it's also not a bad thing to like have built into your report template so you can look it up quickly, because I'm not smart enough to remember this stuff. So A.O. Smith water heaters and technical bulletins. This is actually really good little link. Have you guys linked to this? You guys know about this one? But A.O. Smith has a technical bulletin, and it's got all these different things in here about water hammer, heat traps, mineral buildup, aluminum hydroxide, condensation, puddle on floor. So, and there's a lot of really good information here. So I have a link to this in my report template so that I can look up weird stuff that comes up on water heaters. Aluminum hydroxide. You'll hear popping. You guys ever hear water heaters that like make a weird popping noise, you know? So one of the things that it could be is aluminum hydroxide. See how they have the sort of, you know, crackling, I guess. If there's mineral buildup, you can get a crackling. Heat traps, you get a rumbling noise. Water hammer is a pounding. Condensation could be a ticking, probably, you know. Anyway, so you can like click on all these things and there's all this information here. Thank you, Hollis. So symptoms: cracking, gurgling, or popping noises from a new water heater cause in a few isolated parts of the United States where the water supply has been relatively high pH. Water conditions will react with the aluminum anode to form excessive amounts of aluminum hydroxide on the anode, and in the bottom of the tank, aluminum hydroxide looks like jelly beads or green, blue, gray gel. The substance in the heater to fix. This procedure should only be performed by someone with the ability, blah, blah, blah. So if the tank is new with no lime buildup, you can turn off the water heater, remove the anode, flush the tank thoroughly with water, replace the aluminum anode with magnesium anode. So they're suggesting you get a different type of anode if this problem is happening. This is what's kind of cool. There's another one that I run into where sometimes the hot water particularly smells like sulfur, you know, and the anode, I think, is often responsible. So I will give links to this to try to, again, you don't have to do this stuff, but to me, again, this is like Charlie's anticipatory report writing of like, I'm trying to provide information to get out in front of some of these things so that they don't, you know, spin their wheels endlessly on it. But it can be complicated stuff to know for sure what's wrong. So if the tank is new with lime buildup to any degree, they have a different set of directions. Turn off the water heater, drain the heater, remove the anode, add unlime to the tank. So now they're like suggesting you put stuff in there to de-lime the tank. Water conditions. So this is group 2 of their A.O. Smith's bulletin is discolored water. And by the way, I have an addendum link. Every set of directions I put in here, I have linked as a hot link to a couple slides that I'll try to get to Hollis if you guys want to share it with everybody, you know, so that you can have all these directions. So anyway, this group 2 is you've got all these conditions: discolored water, smelly water, chlorinization procedure, milky water, mineral buildup, water solutions, and you can go through and kind of find answers to things. So rusty, brown, black, or yellow water. Complaints of discolored water are commonly blamed on water heater storage tanks, but in fact are rare occurrence in today's high water quality glass-lined tanks. The most common cause of rusty water is non-toxic iron-producing bacteria. The requirements for bacteria to thrive are elevated iron and manganese in the water. I think the manganese where I am is a real cause of this. Water with little or no dissolved oxygen, temperatures below 138 degrees. Essentially, this would be another reason to maybe turn the water heater to 140 and have a mixing valve on it, you know. Items that can increase the potential for bacteria, water softeners, well water, long periods of no water movement. Since there are no simple ways to correct pulsation water supply, removal of the heat traps is sometimes the only practical alternative. Anyway, I think they go through some different things you can try, but this can be tricky when we find, you guys comment on odorous water in the house? I do, you know, and I have a comment of like, you could start with flushing the pipes. I think I have one part of my comment is like, it can often help with starting with the cheapest and most easiest solutions and working your way back, right? I mean, if something like this, you don't want to like replace the water heater to start with, I would like try flushing the pipes, and then you could try replacing the anode, and like, you know, you could try turning up the water temperature, but sometimes these things can take a while to diagnose, so. All right, we'll try to get through Rheem water heaters. We still have a little bit of time. If it's all right, I mean, I kind of designed this class, but I would just go till I run out of time for the most part. So, so now we're on to tankless water heaters. So this is interesting, 4.5 feet above the garage floor. Who knew? I didn't know. If the water heater is installed in a repair garage or a private garage, the direct ignition system should be 4.5 feet. So it includes a private garage. So they've got minimum combustible clearance to combustibles. So really almost none, right? 1/2 inch on the side, 0 in the front, 12 inches from the top and the bottom. Preferred maintenance clearance is 24 inches. Do not install the water heater near vents for heating and cooling unless a minimum clearance of 4 feet is maintained. So whenever you're wondering about clearances, go to the directions. I mean, that's where you'll find this stuff. Clearances to chemicals. The water heater should not be installed near an air supply containing halogenated hydrocarbons where contaminants may enter the combustion air supply. So what if this were near pool equipment or something? That would probably be something to keep in the back of your mind. Avoid installing a water heater in any of the locations: beauty shops, dry cleaning establishments, photo processing labs, storage areas for liquid or powdered bleaches, or swimming pool chemicals. These locations often contain these hydrocarbons. Make sure the proper electrical outlet supply, 120 volt, is available or located near the unit. So would it be acceptable to have an extension cord for one of these? No, right? All models come with a 6-foot power cord. Outdoor installations require hard wiring. That's interesting. Consult with instructions in the outdoor conversion kit. The electrical power supply, 120 volt. A dedicated circuit's recommended for the water heater. Do not connect. So do you guys remember to check that? A dedicated circuit is recommended for the water heater. Do not connect to a GFCI or AFCI circuit. There's a conundrum, right? I mean, especially by modern code. Like, so this is only with Rheem. This is not for all of them. I think Rheem is the only one I found this in. But that was this like, whoa, I can't believe that. Like, where would you put this in a new build? And my friend Charlie Buell called them and they said, like, don't use our equipment. Fascinating, isn't it? I mean, these are like I hope this is just helpful and like inspiring. It's like if you read this stuff, you can end up in these really interesting places that you didn't know existed. And that's the whole point of this class, is to try to like provoke your curiosity to read directions, because you never know what you're going to find. So anyway, a dedicated circuit's recommended for the water heater. Do not connect to AFCI, GFCI. Wild. So you probably won't see a lot of Rheem water heaters in new buildings until they change that in their directions. So this is an illustration Charlie made about, this is amended for WAC for Washington State. So your mileage may vary a little bit, but basically everything on a new build now is AFCI, GFCI. There would be really nowhere to install one of these ream tankless water heaters that would comply with that. This is interesting. Use of cellular core PVCs, CPVs or Rydell in non-metallic venting systems is prohibited, and that covering non-metallic vent pipe and fittings with thermal insulation is prohibited. So the cellular core PVC, they don't want you to use on some of these things. So that's not universal with that cellular core venting. I do find, unfortunately, it's the manufacturers where you find out whether you're allowed to use cellular core or not. All right.
A question?
Yeah, why don't we'll do questions, and I think I got through everything. This was what I was hoping to get through. Yeah.
Just back on dealing with the GFCI and arc fault. The expansion, the tanks are typically powered by 240 circuits.
No, these we're in tankless gas here, so this is 120 volt.
Oh, okay.
Yep, tankless gas ream, and is the ones I was going off of for
Gotcha.
here.
Thank you.
Yep. Yeah. So just to finish the thought, guys, did you guys find this helpful and provocative in a good way? I hope so. I mean, again, the goal was not to like here's how everything should be done, but I wanted to just spend a couple hours going through like, wow, these are all the things you find here, and I hope I inspire you to read the directions some, because I don't like reading the directions, and it's complicated and it's maddening, but I think if you do it over time, it'll just help your company. You'll be better and smarter and more accurate. And I have found it very relieving that there's a lot of things to back my opinions in the directions that provide cover for me, So yeah, question or comment in the back?
Do you have any input on the new cartridge filters I'm finding on the floor on the condensate lines in mostly
On the what?
townhouses? Condensate lines, there's like a plastic box laying on the floor with a filter in it for condensate.
For the furnace?
Yeah.
Yeah, that would be one that I could unpack. It's funny, I live on an island where there's no natural gas. So most of my stuff's heat pump condensation, which has different stuff because it's not corrosive, But yeah, I mean, the condensate would be like this whole thing you could unpack of like, I encourage you to go find a manufacturer or two and read the directions and see what the requirements are. And usually once you read 2 or 3, if they're the same, you start feeling kind of comfortable with it. The scary thing about the directions is this ream water heater thing. It's like, you can find them that are different and weird. And like, and if you don't read them, you don't know. So I'm sorry if I didn't answer your question, but, but I like, bollards and condensate discharge would be 2 other areas that I feel like we could dive into in this class. Yeah.
So I would imagine if you ask anybody in this room what the most common issues are for any particular system, we'd probably agree on most of the things. My question to you would be, what are the most common manufacturers' directions that you find yourself going back to and using more often than others?
These ones. I mean, I kind of built this class somewhat organically of like the things that I was just checking when I was doing inspections. And that's kind of, I think laughing with Hollis about this, but I feel like I could make this like a 10-hour class eventually as I keep, when I'm out, I find a question and I go look it up. And I feel like I could keep adding more and more things, but that's why I put these ones in, are the things that I was running into in my inspection, which is tricky because you guys out here in Maryland might run into different things than I do, Anybody else have directions they go to a lot? It sounds like you guys look stuff up, or some of you here. So I don't know if there's ones in Maryland that you're running into all the time that you're looking things up. No.
Well, I've got to get my hook out.
Yeah. Okay. Cool.
All right, thanks a lot, Don.
Yeah.